4.5 kilogram steel ball strikes a wall with the speed of 13 meters per second and an angle of 60 degrees with the surface. It bounces off with the same speed and angle. If the ball is in contact with the wall for 0.2 seconds, what is the average force exerted by the wall on the ball? Assume right and up are positive directions.
Since the problem tells us that up and to the right are our positive directions, these are the directions in which our coordinate axes will point. So since the problem is asking us to determine the force, we can start off with our general equations for force. Force is the time derivative of momentum. But since we know that momentum is mass times velocity, we can substitute that in. Since we know that mass is constant with respect to time, we can take that out of the derivative. And since the problem is asking for average force, not instantaneous force, we can change the dv dt to just delta v and delta t. And there we go, we have our equation for force. Force is equal to mass times the change in velocity over the change in time. That's all fine and dandy, but what's the change in velocity? To determine the change in velocity, we must first find the original velocity and the final velocity in its vertical and horizontal components using, you guessed it, trig. This triangle relates the magnitude of the original velocity to the magnitude of the original velocity in the x and the y directions. So we know that the magnitude of the original velocity is 13 meters per second. Using this in some of our favorite trig functions, we can deduce that the original y velocity is equal to 13 meters per second times the cosine of 60, which turns out to be 6.5 meters per second. For the x direction, we know the original x velocity is 13 meters per second times the sine of 60, which turns out to be 11.258 meters per second. Notice here that both of these values are positive because they are up and to the right, which are defined as positive through our coordinate axes. Similarly, for the final velocity, we also have a triangle. Since we know that the ball bounced off the wall with the same speed it had before, we know the final velocity also has a magnitude of 13 meters per second. Since this angle and this angle are alternate interior angles, we know that they have the same value. Using some trig, we can determine the final velocity in the y direction to be 13 meters per second times the cosine of 60, again equal to 6.5 meters per second. Now, this is where it gets tricky. The final velocity in the x direction is 13 meters per second times the sine of 60, but it has to be negative since it is pointing in the opposite direction of our coordinate axes. So this turns out to be negative 11.250 meters per second. So now that we have the original velocities and the final velocities, we can calculate the change in the velocities. So the change in velocity in the horizontal direction is the final horizontal velocity minus the original horizontal velocity. And this turns out to be negative 22.50 meters per second. In the vertical direction, the change in velocity is again equal to the final vertical velocity minus the original vertical velocity. So, but both values are 6.5 meters per second. So 6.5 meters per second minus 6.5 meters per second is equal to 0 meters per second. This means that during the collision, the ball experienced no change in vertical direction. It was moving 6.5 meters vertical before collision and 6.5 meters after the collision. So using this equation that we have for force, mass is equal to the change in velocity over the change in time, we can get directional specific equations. Let's start with the force in the y direction. So the force in the y direction is equal to the mass times the change in the vertical velocity times the time. But we know that the change in the vertical velocity is 0. Therefore, the total force exerted in the vertical direction is 0. Now for the trickier one. We have the total force exerted in the horizontal direction is equal to the mass, which is 4.5 kilograms, times the change in horizontal velocity, which is negative 22.5 meters per second, divided by the time, which is 0.2 seconds. Plugging this into your calculator yields a force of negative 506.6 newtons. You might be asking yourself, why is there a negative sign in front of the force? Well, this is because the total force exerted is in this direction, which is opposite to the direction we declared positive using our coordinate axes. The challenges I faced when solving this problem were related to determining the change in horizontal and vertical velocity. In the horizontal direction, I simply added up the magnitudes of the velocities, which resulted in a positive 22.5 meters per second. I forgot to account for the opposite direction of the final velocity. I made the same error in the vertical direction. I added up the original and the final velocities when in order to calculate the change in vertical velocity, I had to subtract the original from the final. This problem shows my growth as a physics student because it shows that I'm able to take an equation with some calculus in it and simplify it down in the terms that we understand. Also, through determining the horizontal and vertical components of the velocities, it shows that I still have not lost all of my trig knowledge. One last thought. Make sure you have a good 2 for Tuesday.